Well, the fundamental promise of NFV is to lower the cost per bit of the entire network infrastructure by lowering the CapEx as well as the OpEx. And to achieve that, what NFV really brings to the table is decoupling the software from the underlying hardware resources, really then enabling a wide variety of different network functions to be either multiplexed and share an underlying hardware resource, or if you have a particular network function that needs to be scaled, you can elastically scale and allocate more resources dynamically to that particular network function. And thereby, by decoupling this and sharing of resources, you can A, drive the hardware utilization up, and B, lower the total amount of hardware resources you would otherwise need in a network, and thereby drive the CapEx lower. Now, when the network is operational, you can also lower the OpEx by only utilizing the hardware resources that you need on off-peak traffic network conditions, and thereby reduce your energy costs and reduce your cooling costs, etc., and overall drive the OpEx of the network lower. The lowest common denominator to achieve all of this is to achieve homogenized hardware platforms. Well, virtualization in the context of data center has been around for a while. It's lived in the data center for a long time. However, look inside a data center and it lends itself very well for homogenized workloads. So in a way, it's been the low-hanging fruit that's already been plugged. Now, virtualization in the context of telecom networks is something new, virtualizing different network functions. From a Radisys standpoint, we are already introducing a lot of these concepts in our products that we offer. Most importantly, we bring open standards-based COTS, ATCA platforms to market, which have been widely deployed in telecom networks. And now we're virtualizing these ATCA platforms, enabling operators to run virtualized network function workloads on these standard COTS-based platforms. Further, we have our own media resource function, a complete network function that gets deployed in IMS. With our MPX product offering, we've completely virtualized our MRF, which can now be hosted in the cloud, enabling operators to offer media processing as a service. If you look at the real premise behind NFV, it's all about hardware resource sharing across a wide variety of network functions. It's also about elastic scaling of a particular network function. And to achieve that, you need homogenized platforms. Now, if you look at the telecom network itself, you can pretty much divide it into three layers. You have the service layer, which is all delivering different kind of services, primarily sitting in the IMS domain. That layer lends itself very well to be run on homogenized platforms and lends itself very well to be virtualized. Then you have the control layer, which is the brains of the network, controlling all the things that happen in the network. Again, most of the control plane functions run on x86-like architectures, run on homogenized platforms, lend themselves very well to be centralized, virtualized, and to NFV principles. Then you have the data plane layer, which is the bronze of the network, the one that's doing all the heavy lifting of packets. And when we look at the data plane, it does not necessarily lend itself very well to, I wouldn't say virtualization, but centralization, because the very premise of the data plane layer and network elements sitting in there is to deliver packets to the right place with the right quality of service. And if the packet has already been delivered to the cloud, to the data center, then you don't necessarily need those. And in that context, we see the need for microclouds for data plane. So when we look at service plane and control plane, we see that can be centralized and go in the telecom cloud, but for data plane, need for microclouds. This is where we're really talking about the real-world implications of Moore's law. We're talking about specialization versus commoditization. So let's take a look inside a telecom network. And what we have is different kind of network functions. You have control plane network functions that require high number of CPU cycles and typically would handle small number of packets. And these workloads lend themselves very well to run on x86-like architectures. Then you have data plane workloads, which are dealing with very high number of packets and typically would require very small number of CPU cycles on a per packet basis. Would require network processors, or with DPDK, you could run them on x86-like workloads. And then you have media plane workloads, which are doing media processing. And these workloads would do a lot of signal processing and typically would require DSPs, specialized processors, so on and so forth. So go to the next layer, look at it from a platform perspective. And the underlying platform for NFV must be modular, that must be virtualized, must have lots of x86 payloads, but must also be flexible where you can adapt and have specialized payloads where needed. And so the underlying principle has to be virtualize what you can, specialize what you must. And so from an ATCA perspective, it's the open standards-based COTS platform that's flexible and enables virtualized x86 payloads, but also specialized processors when needed. Further on, the platform itself needs a lot of software capabilities on it. So think of load balancing, so you can plumb all the traffic that comes in and load balance across different payload blades. Requires SDN capabilities, so you can take the packets and deliver them to the right network functions, and also enable VM migration that might be needed. Must support VXLAN for tunneling, must support for VRF from a routing perspective. So a lot of capabilities that the platform must support. Must support providing the right KPIs to the orchestration layer. So the orchestration layer has visibility into platform resources and VM migration as and when needed. So that's how we see the equipment evolving. When it comes to telecom infrastructure, the fundamental requirements of 5 nines, high availability, those are not going to be compromised by the network function virtualization by the telecom cloud of tomorrow. So the underlying platform requirements will have to meet the high availability needs, the 5.9 resiliency, the serviceability aspects that the telecom infrastructure needs. Clearly, we know that there are very stringent regulatory penalties, and more importantly, risk of tarnishing brand when it comes to network outages. So I don't think there's any debate around that. From a telecom perspective, the key thing is to look at what can be centralized and what cannot be. So I think the guiding principle has to be centralize what you can, distribute what you must. And in that context, bring in the right virtualized hardware platforms in the telecom cloud, but also then look at micro clouds that might have to be distributed given the hierarchical nature of telecom itself. And again, within the workload types of telecom, I again tend to believe that the guiding principle has to be virtualize what you can, specialize what you must. And so from a platform perspective, the ideal platform must be open standards-based, commercially off the shelf, highly virtualized, modular, yet flexible, where specialization is needed. And I think from that perspective, we see ATCA to be the right platform for network function virtualization. From a Radisys perspective, given a strong telecom pedigree, we've been in the telecom ecosystem for 25 years, we are going to lead the path when it comes to the right requirements for the underlying platforms for network function virtualization. And we are already doing that. We bring to table the open standards-based, commercially off-the-shelf ATCA platform that truly enables the operators to ensure this time round they don't get a vendor lock-in. Not from the TEM proprietary platforms to IT proprietary platforms, rather have true open standards-based platforms. A platform that's modular, that's virtualized, and that's flexible. More importantly, we are adding all the right capabilities on the platform, i.e. think of load balancing and stateful load balancing, telecom protocol aware load balancing. We've already rolled out our GTP load balancer, for example, in the networks, and we're bringing that on our ATCA platforms. We are adding all the key SDN capabilities, things of VXLAN capabilities, VRF capabilities, which are essential to bring in virtualized network functions, virtualized workloads on the platforms. We are then also extending our management capabilities to provide the right KPIs to the orchestration layer. And oh, by the way, in case of microclouds, I think data plane, these platforms can be deployed in the data plane as microclouds and can have multiple data plane network functions, virtualized network functions run on them, and they can be service chained. So that's what we're doing. On the other hand, we have our own network function with our MRF. And we've already virtualized that as well, making it ready for the telecom cloud.